In algebra, one of the major tasks is to write a given expression in its best way whenever possible. Most of the time, the best way is the expression in its simplest form. For example, 4x minus 3x plus 2x minus 8x plus 4x. This is equal to 4 minus 3 plus 2 minus 8 plus 4 x's. And that in turn is equal to, so this reduces to minus x. And that is certainly a lot better. Consequently, terms which have identical literal coefficients, such as this one, should be simplified by adding or subtracting the numerical parts. Terms with identical literal coefficients are often called like terms. For example, 2a plus 7b minus 3b plus 8a minus 4a plus b. The like terms are 2a plus 8a minus 4a, and these should be added and simplified. The result for the a term, this adds up to plus 5b. A general rule can now be stated regarding the work applied so far. When like terms occur in an extended expression, simplify by adding and or subtracting them. For example, 6x cubed y minus 7xy cubed plus 2x squared y plus 6xy cubed plus x squared y squared and minus 4x cubed y. Look at the expression very carefully and find those terms that have identical literal coefficients. This is x cubed y. This is not the same. Here at the end, x cubed y and x cubed y, for that part of the expression, we want to write 6 subtract 4 is 2x cubed y. Are there any other like terms in the expression? Examine further. This literal coefficient, 2 of those terms as well. Like terms, minus 1x y cubed. Going on with the remaining two terms of the expression, you'll see that there is nothing in common here between the two terms with regards to identical coefficients, and they simply are added to the final answer. Here's another example. For capital R subscript 1 plus 6 capital R subscript 2 minus 7 capital R subscript 3 plus 2 R sub 2 minus 4 R sub 3 and minus 6 R sub 1. That can be added and simplified to produce negative 2 R sub 1. The next R we want to look at are the ones with subscript 2, and there they are. 6 and 2 is 8, and so we want to write plus 8 R sub 2. And finally, minus 11 R sub 3. Another example, 3x squared y plus 2xy plus 15x squared y minus 6xy. These two terms have identical literal coefficients, and so consequently are like terms, and we can add 3 of those and 15 of those to give 18 x squared y. Finally, 2xy minus 6xy makes it minus 4xy. Another example, 4x plus 2y minus 3x squared minus 2 plus 8x minus y plus 24. All those are like terms. We can add them up as 2. 4 is minus 14x squared. And lastly, so plus 19 is another example. 4x minus 2y minus 6y plus 2x in brackets. And so 4x minus 2y minus 6y minus 2x. Simplifying, 4x minus 2x is 2x. Adding these is minus 8y. Another example, we have 5x minus brackets 3x plus 2y minus 4x plus y in brackets. We have nested brackets here, and we'll look after the interior brackets before we deal with anything else. And so, all these other parts are not changed, but this becomes minus 4x minus y. We can now simplify what we have within this set of brackets, and that's negative x plus y. This negative sign expects you to change the signs inside of the brackets, resulting in plus x minus y, and finally 6x minus y is the result we want. We will now do examples where we subtract. For this problem, want to subtract 4x cubed y minus 7x y cubed from 2xy cubed plus 2x cubed y. This is usually how the question will be written on a test. The point is that the key word in the question is the word from. You must write the two expressions in the correct order to avoid mistakes, then you have to write 2xy cubed plus 2x cubed y first, and then subtract 4x cubed y minus 7xy cubed. Doing it the other way. 2xy cubed plus 2x cubed y. This is minus 4x cubed y. Minus 1 times minus is plus 7xy cubed. 9xy cubed is part, and we have minus x cubed y, the simplified form of that part. To compare this to another way of subtracting, which is called vertical subtraction, we will, for subtracting this from this, in vertical subtraction, we want to write 2xy cubed plus 2x cubed y first, followed by 4x cubed y minus 7xy cubed underneath. So minus 7xy cubed will go there. And the plus 4x cubed y will go over there. Change the sign of the second group of terms. The positive 7 and 2 is then simply 9xy cubed. This is equal to negative 4 and finally negative 2x cubed y, and that's the same result as we found earlier. Example, subtract x squared minus 10x plus 2 and 3x squared minus 2x plus 5 is then negative 3 when added is negative 2x squared. This is positive, add, that's negative 8x. This is negative, when you add, it's negative 3. Another example, subtract 4x squared y minus 3xy squared plus 2x from, careful of that word, from, 8y minus 13xy squared minus 4x squared y and plus x. Let's do this solution by vertical subtraction. The first expression has to be this one. 8y minus 13xy squared minus 4x squared y plus x. Taking each term by term, placing them in the correct place, taking into account like terms, we have 4x squared y, and that must go over here, plus 4x squared y. The xy squared term goes over here, it's minus 3xy squared. And finally, plus 2x will go here. When you subtract, we have 8y subtract 0, leaving 8y. Subtract, change the sign and add, minus 10xy squared. Change the sign and add, minus 8x squared y. Change the sign and add, and it's minus x. Another example, want to subtract 3a squared b plus 2ba minus 7yx from 3ab squared minus 7ab plus 6xy. Now, let's do this subtraction vertically. We will therefore write this expression first. 3ab squared minus 7ab plus 6xy. The first expression is written next. 3a squared b. There is no a squared b in this expression to match the term we're looking at as a like term. So let's just put it over here on the side, but of course it'll be the second row of, it'll belong to the second row of terms. Here we have plus 2ba. Well, it's the same as ab and therefore a like term, therefore 2ba can be rearranged and written under the 7ab as 2ab. Similarly, minus 7yx is the same as xy. Simply rewrite it in the other order, and there you have it. This amount, 3ab squared subtract 0, is 3ab squared. This is minus 9ab. Change the sign, add, it's plus 13xy. Change the sign here and add it to 0. There's no term there, so simply assume 0. That's negative 3a squared b, and that's your difference. The next topic is multiplication and division. Multiplication and division of monomials is a simple extension of the rules of exponents. For example, 3x squared y squared multiplied by minus 4x to the 4th, y to the 5th, and z. Have negative 12, the rules of exponents there. Add exponents, and x to the 6th is what we want. Finally, y to the 7th, and lastly, z. Another example, we have 3x to the 3rd, y squared, divided by negative 4x to the 4th, y to the 5th, z. Again, we have a simple problem where the rules of exponents can be applied. 3 divided by negative 4 we will leave as negative 3/4. Negative exponents can be made positive. We take the reciprocal of the base, and so the base goes down at the bottom here, x to the 1. Similarly, there, or y to the positive 3 down below here, and z is left as it is. So negative 3 over 4x y cubed z is the result of that problem. In the next problem we have 7x cubed y multiplied by 12xy to the 4th multiplied by 3xa cubed. Looking the power with the base x, we have 3 plus 1 plus 1 is x to the 5th. Y to the 5th also. That takes care of the powers with base x's and y's, and we're left with a cubed. Another example, I have 2x to the 2xy to the 4th multiplied by 2xa squared b divided by 3xy squared a to the 4th b squared. Taking care of the numerical parts of the expression first, we have 2 times 2 is 4. 4 divided by 3 can be expressed as 4 over 3 simplified. Looking after the powers with base x, we have an x there, and an x there. All together, it simplifies and becomes simply x. Looking after the powers with base y, we have y to the fourth, y to the second below, subtract exponents, and we have y squared left over. And taking care of the powers with base a, we have a squared minus 4, which is a to the minus 2 up there, but we want to take its reciprocal and write it with a positive base, so it goes down below there. And finally, the same with b. We end up with b down below there. The next topic deals with substitution. The variables of an expression are replaced with corresponding given values, and the expression is then simplified. For example, given that x is equal to minus 1, this is an example, and that y is equal to 3, finally that z is equal to minus 2, evaluate y multiplied by 2z minus bracket x minus 3y. This is the same as y square brackets 2z, change the sign minus x plus 3y. But we can multiply by y and end up with 2yz minus xy plus 3y squared. Now substitute. The given values for y and z are 3 minus 2. It's best if you use brackets where the substitution occurs. Replace y with the 3 and z with the minus 2, followed by x, which is negative 1, followed by y, which is 3, followed by the 3 and y squared, which is, again, 3 squared. Minus 2 is minus 12, followed by minus times a minus times 3, which is plus 3, followed by 3 squared, which is 9 times 3. 3 is 27, and this collectively becomes an 18.